Paper 1-3 October November 2020. So this is the part one of this paper. Let's start. The first question is about the estimation that we need to estimate the volume of a regular size football. So the estimated thing is we estimate the diameter of a football is roughly from 20 to 25 centimeter. So after putting it into the volume formula, we will get about 50971 or approximately 6,000 centimeter cube. So 60,000 centimeter cube. So the option C, the right answer of question number 2 is about to finding out the SI base unit. And we know the Coulomb is not a base SI unit, but rest are the units, SI base units. So the question number 3 is which two quantities are both vector quantities? So in all, option B is force and momentum, both are vector quantities. The next question number 4 is about the calibration curve. So we have a graph between a real value of the current and the ammeter reading. Ammeter is actually in the reading is inaccurate. So they the examination the paper isn't given that the ammeter reading is from uh, they have asked that if the ammeter reading says 0.13 milliampere and 0.47 milliampere, so what will be the what will be the actual increase in two readings? So we just put the perpendicular in 0.13 milliampere and 0.47 milliampere to the horizontal, and we see that 0.14 and 0.44 is milliampere is the actual current reading. So just minus it and we will get 0.30 milliampere is actually the difference. So this is the option A is the right answer. So the question number 5 is we have given an equation of t 2 pi under root L over G. This so the equation is 2 t equals 2 pi under root L over G. So if we get G, so that will be 2 pi square over L over T square. So they have given us the value along with the error of L and T. So we need to find out the percentage uncertainty of L and T. So here is a formula to find out the uncertainty of G. So we 0.2 over 87.3 into 100, we will get 0.23% of uncertainty of L, and for T, we get 2.63% of uncertainty. So the equation is adding both errors. So this will be 0.23 multiply the power of T with 2.63. So we will get 5.49, which is approximately for 5.5%. So option C is the right answer. So next is an object moves in a straight line. The graph shows the variation with time to the velocity v to the object. And we know, so that it's the velocity time graph. So this will be the distance 1 covered, and this d2 is in the opposite direction. So displacement is actually d1 minus d2, right? So we get the area under the curve for d1 1 over 2 6.6 1.8, and for d2 we will get this 0.2. So the difference is 0.16. So total displacement is 1.6. So the option is the right answer. The next is Question number 7. An object accelerates uniformly rest to speed v. It so that means initial velocity is 0 and the final velocity is v. And and if then it move at a constant speed, and when it's moving at a constant speed, that means the change in the velocity with respect to time is 0, acceleration is 0. Before that, acceleration was constant, and then after 8 seconds it will reduce its speed to the rest. The total time of the journey is 12 seconds, like this is, and the total distance covered is 60 meters as given. So we need to find out what is the speed v. So if we just sketch the graph of velocity time of the whole journey, so we will get a trapezium, and the area and the trapezium is 60 meter. So we just take out the formula, that is area of the trapezium is 60, 1 over 2, 8 plus the shorter side and the longer side, 8 plus 12 into the height, which is V. So we will get V 6 meter per second. That is option C. Now question number 8. In separate, I have some other video in which I've explained this as well, how we drive this formula. F is equals to density into A into the velocity of the square. So the question says that the question says that there is 400 holes and the box having colors. When we push the button, the color came out from these holes, right? They have given the area of the hole, number of holes, and we know the density of the color, which is 900 kilogram per meter cube, and velocity from which it is ejecting out is 2.5 meter per second. So after all this information, the main trick is only that we need to convert this zero point 0.4 millimeter square into meter square and multiply by 400 holes. So we will get the area, which is approximately, which is equal to 1.6 into 10 to the power minus 4. So that density is 900, area is this, and velocity is 2.5 square. We will get zero point 0.9 Newton, which is option B. Question number 9. Question number 9. A party balloon is filled with air and held stationary at a height of several meters above the ground. The balloon is then dropped in still air. Which statement describes the motion of the balloon from the moment of release until just before it hits the floor? Okay. So the balloon first held stationary. This means it was in, the balloon was in rest position, and then it is falling to the ground. So, which statement describes the motion of the balloon from the moment release until just before it hits the floor? So that means first it accelerate, and then here comes with the terminal velocity, and then it with the same speed it hits the ground. So the balloon de-accelerate continuously, which is incorrect, right? uh, the balloon falls at a constant speed and then de-accelerate? No, because the velocity first increase and then air resistance act to decrease to zero the acceleration, and the velocity become constant. So that means option B is also incorrect. Option C, at a constant speed, not possible because initially it was accelerating. So the balloon initially accelerate, which is acceleration due to gravity, and then reaches at a constant speed. So option D is the right answer. So question number 10 is about the momentum. Momentum says an object of mass m traveling with a speed 5u collide with and stick to an object of mass 5 m traveling in the same direction with the speed u. So this is a momentum case. Coalescence case means it is an inelastic. Inelastic, when it's coalescence case, mass will combine after collision. So the formula will be m1 u1 plus m2 u2 is equal to m1 plus m2 over v. right? Combined velocity. So 5 mu plus 5 mu is 10 mu, and the m1 plus m2 is 6. So m is cancelling with m, so v will equals to 10 over 6 u. So option D will be the right answer.